Yeah, good afternoon, students. Hope the presentation is visible to you. So the first thing is we are going to visualize as well as we are going to create few classifier models with the help of Google's Collaboratory. So the first requirement is a data set. So to get a data set, you can Google it. In Kaggle, plenty of data sets are available. You can download any one data set as you wish. And since you are using Colab, it is advisable to upload the data set, whatever you download from Kaggle, into your drive. And then you can establish a connection, or you can load your CSV file from your drive into this Google's Collaboratory, which is again available in your drive, because once you create a Collaboratory notebook, it will be synced with your Gmail account, so it will be available there. Okay. And already we have downloaded a hard data set, which we have collected it from Kaggle's website, and we have uploaded it in Gmail account. I'll show you. I have a folder named dataset here, where I have uploaded the heart.csv. You can find this heart.csv here. And let me open this heart.csv. And here you can find a lot of attributes, right? As you know, for any classification model, what you need is independent variables as well as dependent variable. There will be more number of independent variables and there will be one dependent variable, right? So first you have to look into the dependent variable, what type of data it is. Only then you can proceed further, whether you can go with regression or you can go with classification. And here, when you look at this heart.csv data set, one of the attribute is age, anemia, creatinine, diabetes, ejection fraction, high blood pressure, platelets, serum creatinine, serum sodium, then sex, smoking, time, and age, height. That's it. No, sorry, I have gone to the second data set. Better I will download and show. Because when I click the arrow button, it showed the next CSV file available. Yeah, this is the actual data set. Okay. From age to time, these are said to be independent variables. And when you look at the independent variables, you have age, which is numeric, which is a discrete value, 75, 55, 65. And the second attribute, anemia, which is 0, 1, 0, 1. It shows 0, 1, 0, 1, which means this is a categorical value in real, and the categorical value is mapped through the labels 0 and 1. And right now we do not know 0 stands for what and 1 stands for what. We should know that to make some decisions or conclusions. Okay, as of now we do not know about that. And the second one is creatinine. Again, that's also a discrete number. Then diabetes, again it's a categorical mapped 0, 1. Probably this will be like if the patient has diabetes, yes, or if the patient has diabetes, no. That is how the 0 and 1 are mapped. Then ejection attribute, again high blood pressure is categorical value, and then gender is also categorical, smoking is also categorical, all other are discrete values. The dependent variable is the last one, right? The dependent variable is the last one, and the name given to this variable is death event. And again, when you look into this is not a real valued target. Again, this is a categorical target. Why I say this is because when you look into the values of death event, you have got only zeros and ones. That shows that it's a categorical one, which means if death occurs, say it may be 1. If there is no death, then it is 0. So based on the age and this clinical reports, they have come to a conclusion or decision the person is dead or not. Okay, like if age is 75 and anemia no, creatinine is 582, diabetes no, ejection 20, high blood pressure yes, then platelets count some 26, 5000, then serum creatine 1.9, then serum sodium 130, then gender male, then smoking no, then some time attribute. Really, I do not know about this. Time 4, then the target is 1, which means the person is dead, right? Again, when you look into this record for this attributes, the patient is not dead. I mean, the patient is alive. Okay, this is what about the data set. So you cannot go for a regression with this data set. You can go only for a classification. And looking at the data set, we have identified which are all the independent variables and which are all the dependent variable. Okay, that is very brief about the data set. Now we shall move on to this Colab. So what we have done is we have created a folder data set in the drive and we have uploaded the hard.csv there. Then we are using some Python commands to link the data set which is available in a folder which is present in the drive. For that, we are mounting it, say from google.colab import drive, then there is a command drive.mount of content/drive. So you have to execute that so that your Google Drive can be mounted with Google Colab. Okay, only for that purpose this command gets executed. And when you run again, it will ask for an authentication key. So to provide this key, you just click on the Gmail account which is synced with, and you will get a code. You copy and paste the code. That's it. So now your Google Drive and your Google Colab is mounted. Okay. Then after that, your data set is available in the folder data set. So you have to change the directory. So we have changed the directory, right? That's fine. So now everything is ready. And to build classifiers in Python, we are in need of some of the modules or packages of Python, say NumPy, Pandas, and for visualization, Matplotlib and Seaborn. These are all the required packages from Python. So we have imported everything here. Just click it, it's imported. Now this is the place where we read the CSV file. Okay. So in order to read the CSV file, pandas object is required, and the pandas object here is PD. So PD.read CSV. Read CSV is a method used to load the hard.csv, right? And this is assigned to data set, which is a data frame, right? Yeah, now the data set is read, and the complete data set is available in this object data set. Okay, so let us check the shape of the data set. For checking the shape of the data set, the property used is shape. So once you click this, it shows, the first one shows the number of rows and the second one is the number of columns. I mean, the value in the first value in the tuple says there are 299 rows, and the second value in the tuple says there are 13 attributes or 13 columns. Okay. Now, if you wanted to display the data set, you have plenty of commands to display the data set alone. And one is the head method. Actually, the head method displays top 5 records, right? So dataset.head, yeah, it displays the top 5 records which are available in the data set. The same way, there is another method tail which displays the bottom 5 records. And you can pass some arguments to this head method. Say I have passed 10, so that top 10 records will be displayed. 0 to 9 will be displayed. Okay, fine. Now, in order to get the descriptive statistics of your data set, there is a method called describe. You have to invoke this describe method so that the descriptive statistics of your data set will be displayed, right? And the descriptive statistics are something like the mean, what is the minimum value for the attribute, what is the maximum value of the attribute, what is its standard deviation, and what is the 25th percentile value, what is the 50th percentile value, and what is the 75th percentile value. Say, for example, age is one of the independent variable. and the count shows that 299. Yes, there are 299 records, and the mean, the average of age is 60.8, and its standard deviation is 11.8, and the minimum age which is available in our data set is 40, and the maximum age available is 95, and the 25th percentile age is 51, and 50th percentile age is 60, and 75th percentile age is 70. This is how the descriptive statistic conveys certain informations about the attributes in the data set. Okay, sometimes it also shows outliers. Say, for example, if the max value is 500, we know age cannot be a 500 for a human being, right? Obviously, we can conclude that there exists an outlier in the data set, so that you can remove the outlier from the data set to get better results, right? Yes. And now if you want to print the entire data set, you can directly give data set. So simply if you give data set, you'll be getting the top 5 and the last 5. I mean your head and your trail, and in between you can find some dots. Okay. If you want to display all the 299 records, there is option for that. Pandas object pd.set option. You have to use this value display.max.rows. If you provide display.max.rows as parameter to your set option method, then the complete data set, all the 299 records will be displayed. See, these are the 299 records. These are displayed. Okay, fine. Then we have to check whether there is any missing values available, because in your data set, in practice, there may be some missing values. So if there are missing values, it should be handled properly. Those missing values may be filled, or you can remove the tuple from the data set. And if there are more number of missing values, you may lose more number of records, so that the number of data instance, I mean the number of records becomes less, which may yield very bad results, right? So if your missing values are minimum, then try to fill it. You can fill up the missing values by means of mean, median, mode. If they are numeric, then you can go for mean or median. And if it is a categorical attribute, then you can prefer mode for filling those missing values. So to check whether your data set consists of any missing values, there is a method is null of. So let me execute this. See, all the attributes are displayed and the count shows 0, which means there is no missing values in this data set. If you have missing values in age, then if one value is not there, then it will return the count as 1. If there are 2 age attributes are missing, then you will get the count 2, right? Then you have to Google and find out the code, and you have to fill those missing values, right? Okay. And since no missing values, we are not getting into that part here. And the next part is visualization. Whatever we have seen so far is only the statistical description of your data. Now we have moved into visualization. So your visualization technique shows how your data gets distributed, what is the spread of the data. Because if your data is normally distributed, you have to follow a different procedure for removing outliers and all. And so in order to look into the spread of the data, we go in for this visualization. Also, you can get more observations, and if you have some domain knowledge, you can get more insights through this visualization technique. Okay, let us try to display the distribution plot of age. When you look at this histogram, you can say that your data distribution is somewhat sinusoidal. You cannot say that this is a perfect Gaussian distribution, because if it is a perfect Gaussian distribution, your curve will be bell-shaped. And in practice, whatever real data you collect, it won't be a perfect bell-shaped Gaussian distribution. If you try to display some indexes, then you will get a Gaussian distribution, because when you follow indexing, there will be some sequence, right? Like 1, 2, 3, 4, 5 up to say 100. So you will be having numbers from 1 to 100, and when you try to plot that, you will get a perfect bell-shaped curve. Other than that, you won't get a bell-shaped curve. As per my experience, I say this. Okay. Yes, you can also do it for other attributes too, right? And then for another, say serum creatinine, I am trying to do the distribution plot. And here, when you look into this, wait just a minute. Give me a minute. Sorry. Zoom it. Okay. Yes. See here Here the distribution goes like this. It comes like this and it goes like this, which means that your data is right skewed. In the left, it is somewhat normal, and towards the right, it is highly skewed, and there may be chances for outliers too, because you have to check whether these two extreme points are outliers or not. Okay, if you have domain knowledge, you can do that. Again, you cannot remove outliers just like that, because for certain use cases, these outliers are the one which help you to do prediction in case of fraudulent detection kind of things, right? Okay. Then let us try to visualize serum creatinine with respect to age using a scatter plot. So see, this is a distribution plot, and this is a sort of univariate analysis, because we are studying only about one variable. In here, this shows the distribution of serum creatinine, and this shows the distribution of age. At the same time, you can also do bivariate analysis, where you are combining two attributes and studying. And there comes scatter plot. So here we have plotted x-axis serum creatinine and y-axis age. So we have plotted age versus serum creatinine. And this bivariate analysis is done with respect to the class, which is your target variable death event. And you can find some blue dots and you can find some orange dots. Your blue dots says that no death, and the orange dot conveys the death. Okay. So as you see, if the serum creatinine level is less than 2, and if the age ranges from 40 to some 70, I mean this portion, within this region, many people are alive, right? Because the majority of the dots are blue in color. Okay, so this obviously shows that if the serum creatinine is less than 2 and if age is below 70, more chances to live. At the same time, if the serum creatinine is more and if the age is also high, then there are more chances for death even to occur. Okay, again, there you can find some outliers. See, 4, though the serum creatinine is some 3.5, it may be above 3.5, I guess. At the same time, the age is above 80, still the person is alive here. This shows that due to other medical reasons or due to other fitness conditions, the person is alive. Okay. So yeah, these are the things, right? So this is how data visualization helps you to observe certain things. Okay. Then we are making a scatter plot, gender versus serum creatinine, right? Yes. Say for example, if 0 stands for female and 1 stands for male, Let us assume like that. 0 stands for female and 1 stands for male. Obviously, when you look into this scatter plot, you can very well say that there are more number of male records in the data set, because the categories which are used to represent gender is 0 or 1. That's why intermediate you cannot find any dots. Either it lies in 0 or it lies in 1, right? And since more dots are here, we can obviously say that there are more number of male persons available in the data set. And here too, you can find if the serum creatinine is less than 2, in spite of gender, the people are live, because here you can find more blue dots, and here also you can find more blue dots which are very close, which are tightly packed, which means there may be behind this, plenty of data instances are available. So the density is more here, right? Yes. So like this, you have many visualization tools available. Many plots are there. You have scatter plot. You have heat maps to find out the relationship between two attributes. And you have box plots to detect outliers. You have join plots. Then what else? Plenty of plots are there. You have line plots to show some progressions, and you can explore those things, right? So these are all kind of pre-processing, data pre-processing. If you have missing values, you have to fill up that. If you have outliers, you have to remove that outliers, right? Then we shall move into classifiers. Plenty of classifiers are there. In your syllabus, you have learned decision tree, naive-Bayes, KNN. So we have tried only that, okay? And for building any classifier for eager learning algorithms, the entire data set should be splitted into 2, right? Imagine this is your entire data set where you have some 1 to 100 data instances available. And for building a classifier model, you need training data as well as test data. So you have to split it. The standard way of splitting is 70 to 30. So 70% of the data will be considered as training, and 30% of the data will be considered as test data. And here, when you do so, here lies all the independent variable, and here lies the dependent variable. So dependent variable is your target. Your age to time are all your independent variables. So you have to split it 70-30. At the same time, you have to separate your independent variable as well as your dependent variable. Okay. So that split is done here. Here in X, we have extracted all the independent variable from the data set, and in Y we have extracted the dependent variable. Okay, and now using this train split function, we are splitting the data, right? We are splitting them into X train, X test, Y train, and Y test. Just a second. This is your entire data. Let us assume this is your 70% data and this is your 30% data, and these are your independent variables, and this is your dependent variables. Okay, so this is your train, and this is your test, right? So now this portion, whatever available in this portion is your X train, and whatever available in this portion is your Y train. Okay, and this is your test region. So whatever available here is your X test, and whatever available here is your Y test. This is how you have to split the data for model building, right? Okay, and now you can check your X train. I think I have missed this. Wait, let me click on this for execution. Yeah, we have splitted it perfectly. Yes, this is your X train. Okay, and this is your X test. So 70% of the data are available as train and 30% of the data are available as X test. Even if you want, you can check how is your Y. Okay. Let me print Y train. There will be only one column. Your dependent variable only will be available. Okay, 70% of Y train. And if you print Y test, you'll get 30% of your dependent variable. Okay, fine. And now let us start with decision tree classifier. And the criterion used is Gini. You can go for either Gini or entropy. And you are creating a model here by passing your X train as well as Y train. And then you have to predict your model with the test data, I mean with your X test. Okay, so for that a prediction method is available in Python. So your model invokes the predict method by passing your test data as argument, and then you are printing what is the accuracy. So for this data set, the accuracy given by decision tree is 86.6%. Okay, and the second one is naive-Bayes approach, which is a probabilistic one, which applies conditional probability, where you have to calculate posterior probability, and you have to apply H-map to get the maximum probabilistic for each data instance with respect to your target. And finally, you can build your confusion matrix, right? Yeah, here the accuracy is 77.7. Then KNN, and for KNN, let me set the value of K as 5, right? So KNN is also a classifier, right? And for this, you'll get an accuracy C 56.6. Now let us fine tune this parameter. Let me change this to 7 and see whether the accuracy has improved or not. Yeah, it has improved. It is 58 now. Okay. Let us give 20. K as 20. The accuracy keeps on increasing. As the number of neighbor nodes increases, the accuracy also gets increases. But this is not possible in naive-Bayes. Always your naive-Bayes gives you 77.7 because it's a probabilistic approach, right? Yes. So these are the three classifiers you have studied in your machine learning techniques course. That's why we have done this. And apart from this, we have tried an ensemble where we have used a random forest classifier, so which yields a very good results with the accuracy 87.7. Again, if I adjust this parameter, say number of estimators, there will be a change in results. Now I have increased the number of trees for decision tree classifier is 600. So you have got 86%. Okay, if I bring down to 100, it is 87. If I bring down to 50, it is 84. It goes on, right? So this is how you have to get a data set. You have to load the data set. You have to apply some pre-processing techniques to prepare your data for model building. Then you can build a model. You can test the accuracies and you can compare the results, right? So I think we are running out of time. So with this, we shall stop the session today. And any doubts you have?